Hello students, welcome to our today's video lesson. So now from next week your midterm exams are going to be start. So we have done all the chapters, we are doing the revision also. I have taken the revision worksheets of all the first four chapters. Okay. Now in this video lesson I am going to discuss with you some important points from chapter number 4, that is atomic structure. Once again, I hope it will definitely help you to revise this chapter for your upcoming midterm examination. Okay students, so let us start with the first topic of this chapter, that is the Dalton's atomic theory. Dalton was the first person who gave an idea of atoms in the modern chemistry, according to modern chemistry, after Maharshi Carnot and Democritus. Dalton said that matter is made up of very minute particles. They are electrically neutral particles. Atoms are indivisible, neither be created nor be destroyed. All atoms of an element are identical but are by mass and property. Atoms of an element of different elements are different. Atoms are the smallest unit which take part in a chemical reaction. Atoms of element combine with atoms of another element in a fixed proportion to form a compound. Molecules number and the type of atom a given compound is always fixed, and the atoms combined, they do so in a simple numerical ratio. Okay, so these are the main points of Dalton's atomic theory. But this atomic theory was discarded later on by the discoveries of different things. First is the discovery of subatomic particles. First electron was discovered, after that proton, after that neutron. Basically these are discovered by first of electron were discovered by J.J. Thomson. Before that an experiment was done in a discharge tube experiment, in which electricity is passed at very high voltage electric current at very low pressure through a gas. After some rays are emitted from the cathode terminal, and the rays are called as cathode rays. After that, these cathode rays have negatively charged particle and they are named as electrons. After that, discovery of nucleus was made by Rutherford. Gold foil alpha experiment, scattering experiment. In this experiment he found that when alpha rays are passed through gold foil, some of the particle of rays without any disturbances, they move forward, but some particles they deflected from their path, and some particles they reflected back to the same path. So from this observation he concluded, he observed that alpha particle pass undeflected to the foil because it has some empty space between the atoms. There so many empty space between them, and something is there in the central part of the atom. When these alpha particles strike on that thing, either they deflected from their path or they reflected back or returned back to the same path. So he found that something is there, and total mass of an atom is concentrated in the central part of it, that is named as nucleus. And after the discovery of nucleus, since electrons are negatively charged particles, so E. Goldstein again have done the same experiment of this discharge tube experiment, and he found that some rays are also emitting from the anode terminal, and he named this anode as, since they are positively charged particles, he named as anodes, protons. And after that it is said that these protons are not kept inside the nucleus, inside the nucleus. But after the discovery of proton and electron and nucleus, Rutherford thought that if the total mass of an atom is concentrated inside the nucleus, then what is there inside the nucleus with protons that completes the mass? Because the mass of atom is just double or nearby double of the mass of the protons. So something must be there inside the nucleus with protons. And he said that some uncharged particles, means electrons are negative, protons are positive, then a third particle which is present inside the nucleus that does not have any charge in them, and he named as this uncharged particle as neutrons. In this way the neutron was discovered, okay, by Rutherford. After that, the difference atomic model was given by so many scientists. J.J. Thomson has given the plum pudding model, which was discarded. Rutherford also gave the atomic model. His model was also discarded because he cannot explain the stability of the electrons. He said the electrons revolving around the nucleus in the spiral path. If they revolve around the nucleus in the spiral path, what will happen due to the two forces, centrifugal force and due to centripetal force? Either this electron will fall into the nucleus or they will split away from the nucleus. So he cannot explain the stability of this electron. So his model was also his planetary motions is also discarded. After that, Niels Bohr came and he gave the modern atomic structure. Now we are following that only. He said that electrons are revolving around the nucleus, not in the spiral path, the fixed path. Each electron have this different fixed path, and this fixed path are named as shell or energy level. These circular orbits, they can jump from one shell to another shell. These electrons, they cannot occupy empty space between them. So they have some inward attractive force and also some outward force of motion of electrons around the nucleus. Shells formed an atomic size and energy. Other size of the shell increases when we move from nucleus outward. Electron normally occupied the energy level called the ground level. It can jump from high energy level by absorbing energy that is equal to the difference in the two energy levels. So this higher energy level, however, has less stable and is called the excited state. The electron can jump from back to the excited state to the lower ground state by releasing the energy. So this is the modern periodic atomic model. According to modern atomic model, atom is the smallest particle of matter which comprises the fundamental subatomic particles, electron, protons and neutrons. Most of the atom space inside the atom is empty. Nucleus is an extranuclear part. Nucleus is a very dense, which is a positively charged central part of an atom, which consists of atom protons and neutrons together, and it's called nucleons. The entire mass of an atom is concentrated inside the nucleus. The extranuclear part comprises orbits or shells, which imaginary path revolve around the nucleus. These imaginary parts are nothing. They are called as shell or orbits or energy level, in which electrons revolve around the nucleus. As we move away from the nucleus, this energy level in the shells goes on decreasing. Okay. So the shell which is near to the nucleus have the highest energy. The number of electrons in each shell is fixed. Suppose in the first shell, K shell, it's having 2 only electrons. In L shell it is 8, M shell it is 18, and then N shell is 32. The formula is given by Niels Bohr, that is 2n square. N means that is the number of shell. So next is the atomic number. Atomic number is equal to number of protons and the number of electrons. They are same as atomic number. The atomic number of an element always remains the same. In fact, it is most fundamental characteristics that distinguish given element from other elements. So modern periodic table is also based on this atomic number. Next is the mass number. Mass number is the number of proton plus number of neutron. It's called mass number. Mass number is represented by letter A and atomic number is represented by letter Z. So number of neutron equals to atomic mass by minus atomic number. So number of neutron is also equals to atomic mass minus number of protons. Next is the isotopes. Isotope means elements having the same atomic number but different mass number. They are called isotopes. And isobars are also there, same molecular atomic mass but different atomic number. They are called isobars. There are so many elements which exist as isotopes, like hydrogen is a 3 isotope, protium, deuterium and tritium. Then chlorine, carbon, oxygen, all they are also having some isotopes. Iso means equal, topes means position, equal position. So after the discovery of these subatomic particles and isotopes, that atoms of an element having the same atomic number but they can have the different mass number, okay, isotopes. And sometime different elements having same electrons or atoms of same mass, okay, their atomic number are also maybe different. So after the discovery of these three things, Dalton's atomic theory was discarded. Now that unified atomic mass unit, so to make a convenient measure the mass of energy atomic level, a new unit called unified atomic mass was introduced. It is defined as 1/12 of the mass of carbon 12 atom. It is equal to mass of 1/12 mass of the one atom of carbon 12. So one unified atomic mass unit is equal to 1/12 that mass of carbon atom. The mass of the atom of an element measured in unified atomic mass is also called atomic mass. So atomic mass of hydrogen is 1 U, that is of oxygen is 16 U. So numerical value of atomic mass and atomic mass number of the atom are practically the same thing. Next, electronic configuration. Electronic configuration means distribution of electrons in different shells around the nucleus to the atom of element is called electronic configuration. It is given by first Niels Bohr. He gave two rules to do the electronic configuration, that is octet rule and duplet rule. Duplet rule is for only hydrogen and helium because they have only 1 and 2 atomic number respectively. So the number of electrons is 1 for hydrogen and that of 2 for helium. So their configuration ends in the K shell, and here only duplet rule is followed. For other shells, L, M, N and so on, the octet rule is followed. In this rule, not more than 8 electrons can be filled at a time in shell. So it is called octet rule. So on the basis of octet rule and duplet rule, we do the electronic configuration, and I have shown you how to do the electronic configuration. And on the basis of electronic configuration, we can also draw the atomic structure of an atom of an element. So you have to practice these structures that given in your book, and I have also shown in the online class and video classes. Next, valency. What is valency? Or you have already studied. Valency is the combining capacity of an atom of an element. If the number of electrons of an atom can accept, donate or share electrons. Okay. So valency you have to learn. So valency you can also find from the electronic configuration. So number of electrons in the valence shell are all called valence electron, and if the valence electron is 1, 2 and 3, it is directly taken as valency. But if it is more than 3, we have to use the formula n minus 8 minus n, or n minus 8 also you can say. So if it is 4, 4 minus 8 is minus 4, so it is valency is 4. It is negative valency, means it represents a non-metal or metalloid. But if it is a positive valency 1, 2 or 3, always it's a metal. Okay. Now molecules is the smallest particle of matter that are capable of independent existence and possesses all its chemical properties. Okay, so you have to remember this. So for example, symbol of hydrogen is H, but molecular formula of hydrogen is H2. Okay, next is the chemical bond. Chemical bond means it is a link formed between atoms when they combine chemically. This link of called chemical bond. Chemical bond is of two types, that is one electrovalent bond and covalent bond. Electrovalent bonds means when an element lose electron and another element gain electron, means the transfer of electron takes place. That is, they form electronegative ion or electropositive ion. That's called transfer of electrovalent bond is formed. But when atoms of an element share electrons between them, one will give, another will take at the same time, sharing will take place. That type of bond is called covalent bond. So I have shown you how to make the covalent bond and electrovalent bond in video lessons. You can go through them again if you have forgotten. So these are the important points from this chapter, students. So you should remember how to draw the atomic structure, how to do the bondings, chemical electrovalent bond and covalent bond, both you have to remember, and all the points regarding in this chapters are very important. This is the basic of chemistry, so you should remember for a long time. In future also you have to study these same chapters in class 9, 10, everywhere it will be needed. So go through the chapter once again, read it properly. If you get any doubt, please ask me in your online class. Okay students, thank you very much for watching this video. See you again in the next video lesson and online class. Thank you very much.